Okay, Nick is a runner whose goal is to complete 4 laps around a circuit at an average speed of 10 miles per hour. If he completes the first 3 laps at a constant speed of only 9 miles per hour, what speed does he need to maintain in miles per hour on the 4th lap to achieve his goal? And this is a footnote over here. I don't always read the footnotes to you, but it's from that Stanford math tournament. Some of the questions are easy, some of the questions are difficult. I don't see this being a particularly difficult question, by the way. However, a lot of times when you read things you don't understand what you've read, it's a hard time to formulate the algebra. We can go to the whiteboard. And again, I have the document in front of me. And, certainly, kind of reading through, and I want to make sure, I got it, Nick's a runner. His goal is to complete the laps around a circuit, average speed of 10 miles per hour, all right? So there's 4 laps. I'm just going to draw like my picture of that over there. I'm going to say, sort of like this over here, that this is the circuit, and he's got to go around 4 times, by the way. He has to, all right? So I'm going to say the distance around the circuit is D. What's his total distance? His total distance is 4D. That's his total distance, by the way. He's got to go around once, twice, 3, 4 times, all right? Now, by the way, he wants his average speed. This is the total distance, by the way. He wants his average speed to be 10 miles per hour. What are we doing? We're doing distance equals rate times time. That's what we're doing. What's time? I have no idea. None whatsoever. All right? So I know that what his plan is to go around 4 times. That's his total distance, 4D. He wants his rate to be an average of 10 miles per hour, but I still don't know the time. But I can write this down now. So the time that's going to take to do this thing over here is going to be 4D divided by 10. That's the amount of time it's going to take to get around the 4 laps if he's going 10 miles per hour. Let me just reduce that, by the way. That's 2D plus 5. I'm sorry, over 5. I'm sorry, not plus 5. All right? So what I want to do is, I know it looks really complicated, but I want to talk about the first 3 laps, by the way. All right? The first 3 laps. So that distance is 3D. That's the first 3 laps. How fast are you going? Well, if you go back and read it, it says he's doing only 9 miles per hour. All right? I'm going to say this is going to be T on the first part. All right? That's the first part of the trip. He does 3 times around. What's it going to be? D. I'm going to divide both sides by 3, by the way. By the way, this is total time. What's D going to be? Sorry, not D, but T. I divide by 9, so it's going to be D over 3 is T1. All right? Let's talk about the final lap, by the way. The final lap is D, and he's going at the requested rate. I have no idea. This is the rate on the 4th lap. All right? Times T2. So it's going to be D over R is T2. Now, what do I know? I know that if I add these times together, D over 3 plus D over R, that's T1, T2, would be equal to total time. And what's total time? It's right over here. It's 2D over 5. Now, granted, you may look at this and say there's 2 unknowns in the problem. Yeah, there is. But the bottom line is I can get rid of D now. D some distance, by the way. Just simply divide both sides by D. You get 1/3 plus 1 over R equals 2/5. All right, there's a variety of ways of doing this over here. What I'm going to do is I'm going to subtract 1/3 from both sides. So you get 2/5 minus 1/3. I'm going to calm down to 15. That's going to be 6 minus 5, which is 1/15. And then I got 1 over R equals 1/15, which means R is 15. Now, if you don't remember what R is, it's the rate in the final lap, which he has to go 15 miles per hour. That's the final answer, and we are done. Thank you.